Today we're discussing dots. So we always have some weird acronym for everything that is math here. So we are talking about dots. Dots stands for, the D is difference of two perfect squares. So of is actually the O. So difference of two perfect squares. So the things that you have to realize is difference means minus sign. 2 means it's going to be a binomial. And squares, what is this perfect square? Well, a perfect square is over here. Let's look at that. So all perfect squares are when you multiply a number times itself. So, or a term times itself. So if we want to get the number 1, 1 is a perfect square because it was 1 times 1. 4 is a perfect square, 2 times 2, 3 times 3. So you always get a perfect square from multiplying something times itself. So on. So it's 5 times 5. This number that you're multiplying it times itself, this one is called the root, where it came from. That is the root. So 5 times 5 is 25, so the root of 25 is 5. Okay? And so on. So variables, same exact thing, but we notice the exponent more. So when we do this one, it's x times x, which we know this already, but x to the 4th is a perfect square, and that's x squared times x squared. Remember, when we multiply, we're adding the exponents. So 1 plus 1 is 2, 2 plus 2 is 4. This one, x to the 6th, is a perfect square. It's a perfect square because it's x to the 3rd times x to the 3rd. Okay? So what you might notice when you're doing this, it's not, the exponent has a very special thing happen to it, or perfect squares exponent are always even. Okay, so if it's a perfect square, if you have a letter with a variable that's a perfect square, its exponent is always even. So like this one, x to the 12th is x to the 6th times x to the 6th. Okay, so the root is always that exponent divided by 2. Good. So x to the 6th is the root. X squared is the root of x to the 4th, and so on. Those are the roots. You simply take the exponent and divide it by 2. All right. So when we're factoring the difference of two perfect squares, you can't just divide like you would in a GCF, which would be nice. What you have to do is you take two parentheses. It's going to be two binomials, and all you have to do is take the square root of the first one and put it here and here, and the square root of the second one and put it there and there. And then we simply have different signs. Okay, so when if you were to go ahead and multiply these back out, the middle terms, when you did the whole box method, so x minus 4, x minus 4. So remember, when we're multiplying, it's the opposite of factoring. So it's basically like weird dividing. X plus 4, x minus 4, Ms. Barris, pay attention. Okay, and then negative 4 times positive 4 is negative 16. So you'll hear you have a positive 4 and a negative 4. These cancel out, and you're left with the x squared minus 16. These pairs, x plus 4 and x minus 4, have a special name because of this situation, because they drop out of their, because the middle terms drop out like this, these guys are called the conjugate pairs. They're a conjugate pair. Cool? So cool. How did life get so cool? All right, so for example, this one, 4 minus 9x to the 4th. With this one, same idea. What you have to check, you have to say, okay, look, is this a perfect, I know it is, so I jumped the gun here, but that's a perfect square, see? 9, perfect square. And the exponent is even, and we have a minus sign. These are all the things we have to check. If any of those things don't happen, then you can't factor it this way. So it's important that you notice all the pieces. So then you just take the square root. Let's change the color because we've already used that color too much. So I take the square root of 4, that goes here and here. It was the first spot, so it goes back in the first spot. Take the square root of that one, goes in the first and the second, in the second spot, and then we just put a plus or a minus and a plus, and that's it. That's all. All right, so let's just quickly do this one, and then we'll just kind of put it all together with what we did yesterday. So is this, I just automatically do it. Can I? And is this allowed? Should I maybe look at it a little closer? Well, this is a perfect square. 81's on the list. 9, perfect square on the list. 8 to the 6th, awesome. It's there too. It's got an even exponent. That's what I'm looking for. But there's one problem. That's a plus sign. Okay, so it has to be, this one is not factorable. Okay, we're using GCF. I'll shut up. Using dots. You can, however, take out a GCF if you do using dots. You can, however, take out the GCF if you want, but it's still a plus sign, so it's not really going to change much. So it's 9 parentheses 8 plus 6. So that's all I can do for that one. So when we say from now on, everything in this class is factor completely, and that just means you always have to see if you can factor more. Can I factor more? So you need to always remember that your GCF, you really should look for it first. If you don't look for it first, it sometimes makes your life a little bit harder. And sometimes you think things aren't factorable. So always look for that first. I like to say he's the king or the queen or the best. Okay? And we got to look for a GCF. So I look at these two terms. I see that there's a 3. They can divide into the 3 and to the 27. So 3 is in the GCF. And then there's an x in both terms. So the lowest exponent, we have x and x to the 7th. So the lowest exponent is x. Y is only in this term, not in the other one. So I can't put y in the GCF. So now I simply factor or divide that out. So it's x to the 6th. The 3's cancel out, and we do 7 minus 1. Minus 3. The x's cancel out. Y to the 4th. No, it's 9. It's okay. If I edited it, I would fix that, but I don't edit. So minus 9. You get to see my mistakes and realize everyone makes them. Okay, so now, okay, I factored once. We're done? No. Okay, you do have to look. Is the results dots? In this case, that's all we have right now. So exponents are even. So take a look. Let's change the color up so you can see. Exponents are even. This number is a perfect square, and there's a minus sign. Check. I can do this more. So whatever you don't factor anymore, you just write. So 3x is done, but you still have to keep it in the problem. Dots is 2 sets of parentheses. And so we take the square root of x to the 6th. That's x to the 3rd. Square root of 9y to the 4th. That's 3y squared. And a plus and a minus sign. Now, we still have exponents, so we should still be looking to see if this can work. Okay, this has a plus sign, so I can't factor this anymore, but this one has a minus sign, so can I? So take a look at it. Look here, this is a 3. That's odd, so nope, we can't do that anymore. We're done. Okay, so just find an exception, and then you don't have to keep going. All right. This one right here, you have 2 terms. I see there's a 4 in both. It's pretty obvious that there's a 4, so I'm going to factor out a 4. X is only in the first one, so I can't go any farther. So I can't use x in the GCF. So factor out a 4. They cancel out here. I'm left with x to the 8th. 4 divided by 4 is 1. So that's my new problem. So 8 is even. 8 is even. 1 is a perfect square. It looks like we have all the makings of factoring using dots. So I'm not doing the 4 anymore, but I still have to keep it. So this is x to the 4th. The square root of of x to the 8th. Remember, just take the exponent divided by 2. And the square root of 1 is 1. So we're going to put a plus and a minus. Oh, but look. Okay, this we have to still see if we can keep going. Now, 4 can't go anymore. X to the 4th plus 1 can't go anymore because it's a plus. X to the 4th minus 1 can. 4 is even, 1 is a perfect square, and that's a minus sign. So it's x squared minus 1 and x squared plus 1. That's this piece factored. Now, the other pieces couldn't be done. And then finally, here we go. 4x, okay, this one's done, the first one's done, the second one's done. This one is x squared minus 1. All of those are perfect squared, and there's a minus sign. And now this one's done. So this is the only one I can factor more. So these get pushed down because they're in the final answer. X squared minus 1 is x plus 1, x minus 1, and then x squared plus 1 just gets brought down because that has a plus sign, so it's done. So this is our final problem, our final answer. It's a lot, but sometimes, you know, you can keep going, and maybe it'll help it yourself later. All right, so that's factoring using dots. I hope you have a wonderful day, and I'll see you tomorrow.